this is solving a radical. So what would we do first? So we're isolating the radical. Good. So we'd add it to both sides of the equation. You're right. So then over here on the left, we have 2 square roots of 4x minus 23 is equal to what?
10.
10. You're right. Okay, now this part's the important part. What do we need to do next? Good. You're isolating the radical completely. So you're going to divide both sides by 2. Very good. So then our 2's divide out, leaving us with the square root of 4x minus 23 is equal to, what's 10 divided by 2? 5. Good. Okay. We've isolated the radical. How do we undo radicals? Okay, so then because this is a square root, we'll square both sides. Very good. So we're going to square both sides of the equation. What happens with our root and our power? They cancel out. Okay, so we have 4x minus 23 is equal to 25. Very good. And then from there, now that we've gotten rid of our radical, what are we going to do? Good. Add 25. Algebraically get x alone. Correctly. Good. Add 23 to both sides. Right? So leaving us with 4x on the left is equal to 48. You're awesome. Then we will divide both sides by 4. We're almost there. X equals 12. Yay. Okay, so those of you that said back in the beginning, somebody did get that answer right. How many of you got it 100% correct? Wow. Awesome. Good for you guys. Okay, good. So that's what we learned in 3-1, right? Okay, so it's been a while. We need to talk about everything that we've learned so far because this test is coming up. 3-2, we learned function operations. So let's go through, given these 2 functions, let's find f times g of x. So you tell me, how do I rewrite this? F of x times g of x. Now guys, you don't need to be taking notes during this part. We already have notes on this stuff. We already learned it. We're just re-going over it. This test is coming up. Okay, f of x times g of x. So, what is f of x? The square root of x minus 2. What's g of x? 3x. So this times 3x. Now tell me from here, what are we going to do? Distribute. That's the exact word I'm looking for. So we're going to distribute. In fact, we're going to double distribute. 3x times the square root of x is? 3x square roots of x. You're awesome. And then 3x times negative 2? Good, negative 6x. Okay, now we kind of stopped here, but then we did talk about, well, actually, we could kind of go further, right? We could kind of go further. Because what is the square root of x the same thing as? What's, Kate, you're right on the right track. What is it? 1. You're right there. So everybody think back to this picture. Does everybody remember the picture of our flower? We have a picture of our flower, and roots are on bottom of our flower, and what's on top? The power coming from the sun. So this piece, I want all of you to think for a second. How would we rewrite that with a rational exponent? I just gave you a hint, so everybody think by yourself for a second on this. How would you rewrite the square root of x as a rational exponent? So everybody think by yourself for a second. Okay, now talk to your group. Ready, go. Talk. How would you rewrite it? Okay, yeah, talk to your group about it. You're right.
X.
What do you guys come up with? Roots are on bottom. What root is it? No. Square root. Group 5, did you come up with something? 1 squared? Almost there. X squared. That's the inverse of the square root, but what is the square root of x exactly equal to? Jaden, you were right on. Tell us. You tell us. X to the 1/2 power, everybody. Roots are on bottom. Hey, I need you listening, because you didn't know it. So, roots are on bottom. This is the square root of x to the 1st power, right? We're going to need to know this today, guys. We have to know this today. That's why I'm talking about it. I'm not talking about it for fun. So roots are on bottom. Does everybody see how I put the root on bottom? The power on top. Does everybody understand that the square root of x is equal to x to the 1/2 power? Remember, this is radical form. This is rational exponent form. Okay, so what we truly have then is 3x times x to the 1/2 power minus 6x. Okay, so could we simplify this further? Yes, we know properties of exponents. Let's sing our song. We're going to need this today as well. That's why we're going over this. When you multiply u, when you divide the u, raise a power to a power and u. Okay, awesome. So what property of exponents are we doing right here? You tell me. When you multiply u, add. So we're adding our exponents. So we have the same base, so we're going to add our exponents. What's 1 plus 1/2? 1 and 1/2. Let's write it in 3/2. Very good. Now, if you had to, guys, you take your calculator. Take 1 plus 1/2. Hit enter. You get a decimal. Change it back to a fraction. You get 3/2. Why not use those calculators if possible? All right. So this would be the final answer. Are we all okay with that? I'm going to push you on this test to continue and simplify it all the way down. Do you all understand how to do that? You're sure? Okay, awesome. All right, now we found the inverse in 3-3. We don't have time to go through this. We're pretty good with inverses though. We've been solving. 3-4, we learned solving rational equations. 3-5, we did real-world applications involving rationals. Okay, so now we're on to today's lesson, 3-6. So everybody's taking notes, everybody's listening, ready to go. So in this unit, we've been learning how to solve all types of themes. That's why we just went over all of those themes. So today we're going to be evaluating logarithms, and we're going to be learning properties of logarithms. Because tomorrow we have to be able to solve a logarithmic equation. Well, to be able to solve a logarithmic equation, we have to take the most basics of logarithms and understand it pretty deeply before we can actually solve the equations. So that's what we're doing today, is getting into the basics, but it's actually quite complex into logs. So that's why we're taking a full day to do this. Okay, so first of all, some of you are probably saying in your head, well, what the heck are logarithms? I'm going to explain it the best I can. So, exponentials. We know what exponential functions are. We've been dealing with them since secondary math 1. Logarithms go hand in hand with exponentials. They're inverses of each other. So a logarithm is just a different way of expressing an exponential function, and it's just going to be in the base of 10. Now, these are some examples of where logs are used in the real world. So noise levels, these are in logarithm form. Noise levels in the real world are in logarithm form. Also, acidity, pH levels, this would be in logarithmic form. And also, earthquake magnitudes. So in the real world, earthquake magnitudes are actually measured on a logarithmic scale. And we will actually do some real-world applications later on in this unit on logarithms. Okay, so here we go. Here's the definition of a logarithm. So a logarithm of base b of a positive number x satisfies the following. So I just told you that logs and exponentials are inverses of each other. So this is what you'll want to write down. So we might have something of the form log to the base b of x is equal to y, and that's if and only if. So IFF means mathematically, that's a mathematical if. It means if and only if. So log to the base b of x is equal to y if and only if b raised to the y is equal to x. Now everybody look at this piece. You all recognize that as an exponential function, right? That is the form of an exponential, right? So these two things, this is how you can rewrite it in log form. These two things are inverses of each other, and we've got to be able to switch back and forth between the two. So why do we want to know inverses? Well, think about it. This whole unit we've been solving. To be able to solve, you have to know inverses. So that's why we have to know the inverse of an exponential and the inverse of a log, and so on. So everybody pay close attention to how I read this. Log to the base b. So the base b is little, it's down in the little corner. So log to the base b of x is equal to y. And then once again, this is base b. B is the big thing right here. Base b raised to the y power is equal to x. So we're going to have to be able to switch back and forth. And I'm telling you they're inverses of each other. Okay. So now here's how algebraically we get the inverse. So this is the inverse. I'm telling you this is the inverse. So this is how algebraically that happens. So everybody pay close attention because we're going to need to be able to do this in a second. So we have log to the base b of x is equal to y. Now I want to undo log to the base b. So to undo log to the base b, you're going to take base b of both sides of the equation. That way, base b and log to the base b, those are inverses of each other, so those cancel out, leaving us with an x on the left. So we have x is equal to, and we took the base b of both sides, so that's going to be base b raised to the y power on the right. So everybody look, this is exactly what we had in the last slide. That's just algebraically how I found it. See, look, x is equal to b to the y power. That's how algebraically it happens. We're going to be doing that with lots of logs today. Any questions on that? Okay, b to the y is equal to x. If we want to rewrite this using, if we want to take the inverse of this and write it as a log, if we have base b to the y, we want to undo base b, we're going to take the log of base b of both sides. So the log of base b of both sides of the equation. That way, on the right, log to the base b and base b cancel out, and we have y is equal to log to the base b of x. So this is taking the exponential and rewriting it as a log. Now if I went back 2 slides, this is exactly what the inverse was. So we've got to be able to switch back and forth. Do you feel okay about that for a second? Well, we'll practice a few more, but do you somewhat understand how logs and exponentials undo each other? Okay. So let's do our first example here. So this says, write the log as an exponential and evaluate the log. So we're going to write this log. Given this log, we're going to write it as an exponential, and then we're going to actually evaluate it, solve it. So we have log to the base 5 of 125. We don't know what that's equal to, right? We're going to calculate that. So let's say, okay, that's equal to x. Because we don't know what it's equal to. Does everybody see what I did there? So then from there, I want to rewrite it as an exponential. So I'm going to take, since it's log to the base 5, I'm going to take the base 5 of both sides of the equation. That way, on the left, log base 5 and log to the base 5, there's our inverse, cancels out. That's awesome, we got rid of our log. So on the left, we have 125 is equal to 5 to the x power. This is in exponential form, this is in log form. These are inverses of each other. Now, can't we solve for x? Pretty easily here. What value of x would make this equation true? You tell me.
5.
Not 2, not 5. So if we think about it, guys, 5 to the first power is equal to 5. Isn't this in the exponent? Okay, 5 to the second power is 25. So 5 to the third power is 125. So x must be equal to 30. Very good. Does everybody see why we would want to switch from a log to an exponential? Because then we can solve quite a bit easier. Okay, awesome. Yes?
So, question, like with the calculator, I didn't log was
Okay, we're going to get to that because you're probably thinking, well, we have this schmancy calculator and there's a log key on there. Can we use that? We'll talk about that in a minute, okay? All right. All right, let's do this one. Here we go. Log to the base 4 of 1 over 16. We're going to rewrite it as an exponential. The first thing is to set it equal to x because we want to evaluate it. We don't know what it's equal to. So now we need to undo the log. Well, it's log to the base 4. So we're going to take base 4 of both sides of the equation. That way, my log to the base 4 and base 4 cancel out. We're left with 1 over 16 is equal to 4 to the x power. Now this one is a little bit trickier. Can anyone tell me, just curious, right off the bat, thinking about it, can you tell me what the answer is going to be for x? Oh, you're right on. Yes, that's awesome. You're so right. How do you know that?
Because it's this 1/16 and it's not a whole number and this one is so if you're trying to like an increase.
Okay, yeah. So this is what Melissa said. We have a negative exponent, that's for sure. But why would that be true? It's a fraction. What do negative exponents do? They flip over a fraction, guys. So let's think about it. What is 4 squared? 16, but this is 1 over over 16. So what would it be? 4 to the negative 2. Very good. We take that, we flip it over a fraction. That's 1 over 4 squared. So we get 1 over 16. Very good. Very good. Way to see that. It was a negative exponent. So x is equal to negative 2. Awesome. Does everybody see how to do that? You could just find what it is, and then it should make sense that if it was negative, it would take it and flip that answer over a fraction. So 4 squared is positive 16, and then if we have negative 2, it would take it, flip it over a fraction, so that would be 1 over that answer, 1 over 4 squared. Does everybody get it? Okay, so now I want you to practice 1 through 4. Ready, set, go. So now we're going to go the other way. So it says, what is the log form of this equation? So now look at the statement. It's a true statement, right? 6 squared is 36. Awesome. Now we want to know that you can rewrite this in logarithmic form, okay? So now it's base 6 raised to the second power. So we're going to take log of base 6 of both sides, log the base 6, log the base 6 of both sides of the equation. Now over here on the left, log the base 6 and base 6 cancel out. They're inverses of each other. So we have 2 is equal to log to the base 6 of 36. This is in logarithmic form. So we went from exponential to logarithmic. Questions on that one? No? Not at all. Okay, awesome. Let's do another one. 1 is equal to 3 to the 0 power. Now everybody look carefully. This is where a lot of students make errors because they're used to seeing the base on the left side of the equation, but it's on the right. Now notice the base is always going to be what's raised to the exponent. So in this one, a lot of people tend to want to do log to the base 1, which doesn't exist. But with this one, we're going to be doing log to the base 3 of both sides. Does everybody understand that? Okay. So log to the base 3, log to the base 3 of both sides of the equation. So over here on the left, we have log to the base 3 of 1 is equal to, and then on the right, base 3 and log to the base 3 cancel out. Those were inverses of each other, leaving us with 0. Okay, questions on that one?
Would you have to include the 1?
Yes, you would have to include the 1. Good question. Yep, and this one you would have to include the 1. Really good question. All right. Okay, what about this one? We have 8 over 27 is equal to 2/3 raised to the 3rd power. We're going to take log to the base what of both sides? Good, 2/3. Does everybody understand how 2/3 is what was being raised to the power? That's the base. So we're going to take log the base, 2/3 of both sides. And that way on the left, we have log to the base, 2/3, and I'm going to urge you to write this correctly. That is little. It's the base down here in the log. And then 8 over 27 is equal to, and then base 2/3 and log to the base 2/3 cancel out. That's our inverse, and that's equal to 3. Awesome job. Okay, do problems 5 through 8. I'll leave this up there for a second. Do problems 5 through 8. Ready, set, go. Okay, so now McKay presented a good point to me because he said, you're welcome. He said, well, you know what, Ms. Christensen? There's a log key on my calculator. Can't I use that of some sort? So fun fact for you. If we looked at something like this, log to the base 7 of 49 is equal to x, we know that we would rewrite this as an exponential because then it would be easy to solve. So we take base 7 of both sides. So I just want you looking at this with me, guys. So I'm getting to a point here. We take the base 7 of both sides so that our log of the base 7 would cancel out. And we'd have 49 is equal to 7 raised to the x power. Well, now it's easy to solve. X is what? 2, guys. X is 2. But now this is the problem right here. Let's look at something like this. Now let's see if we can actually figure out the answer. Let's say we looked at this log equation and said, okay, I want to solve it. So I'm going to change it to an exponential. Cancels out, so we have 5 is equal to 7 to the x. Can you think of an x that would equal 5? 7 raised to what power is going to equal 5? You're going to guess all day long for the rest of your life and not get it right. Because it's some crazy decimal, okay? So, cool thing is, you're right, we have to use our calculator. But notice, everybody look at your calculator. It says if you type in log, it does not have it doesn't give you the opportunity to type in a base. It does not give you an opportunity to type in a base. So that's when these mathematicians came up with the change of base formula. They spent their life slaving away into logs, and they came up with the change of base formula. So here it is. We're not going to prove it. We're not at that level in here. There's no need. So here's the change of base formula. We're going to use it. So guys, here it is. Log of the base A of B. We can rewrite it. We're going to change the base so that it's base 10, because our calculator only has log to the base 10. So we're going to change it to be this. So we have log to the base A of B. How you can rewrite it, that's equal to log to the base 10 of B over log to the base 10 of A, which is equal to log of B over log of A. So fun fact for you, base 10 goes without being said that it's not written. So see how I wrote 10 here, highlighting it? Base 10 is not written. So just like a square root is not written, the 2, if there's nothing written here, it's base 10, which is awesome, because that's what our calculator can calculate. Does everybody understand that? So here's a little trick for you to help you remember. So every time I see this, and I have seen this on ACTs, you will see it on the end of level. You look at this, you're given log of the base A of B. An easy way I say, okay, I'm going to evaluate this using the change of base formula. An easy way to remember which one goes on top. An easy way to remember which one goes on top. It's always the bigger in size. So I didn't say bigger in number, bigger in size. Does everybody understand that? So you'll take log of the bigger size divided by log of the smaller size. Does that make sense? Look, log of B over log of A, but we don't write the log of B over log of A. Does everybody understand that? You've used the change of base formula. So let's do number 19 on your worksheet. Here we go. So here we go. We have log to the base 3 of 2.49. Now if we rewrote this using an exponential, just like we were at the beginning, we wouldn't be able to figure it out. So we'll just use the change of base formula. So change of base formula. We know it's log of 2.49, that's the bigger thing, divided by log of 3. These are base 10 now, so you can use your calculator. Does everybody see how I set it up? Log of 2.49 divided by log of 3. That's base 10. I'm telling you it's base 10, but it goes without being said that it's base 10. So now you'll use your calculator. So I'm going to pull mine up. So you go like this. You just type it in. Oh, yeah, hurry up.
Getting salty.
Yeah. Okay, so from here, guys, you'll type it in like this. Log of, I need to be able to see, log of 2.49, close your parentheses, very important, divided by log of 3. Log of 3. And you hit enter. So 0.8303955088. That is the answer.
Do you have a change in the fraction?
Nope, this probably won't, nope, we'll leave it like this. Let's go 4 decimal places. Now let me show you something cool. Let's say we wanted to check, so everybody write down the full decimal really quick. 0.8303955088. So, we could check our answers, because even I will get such a weird answer. I'm like, that can't be right, and then I check it and it's right. So this is how you could check it. So you would go like this. Okay, I'm going to rewrite this as an exponential. So this would be base 3, right? Everybody? So we have 2.49 is equal to 3 to the x power. Now type in, our answer was 0.88.
3039558.
Okay, so that's our answer for x. So type that into your calculator. 3 raised to that, and guess what? You hit enter, and you get that answer. So you can always check your answers. I always have to, because I always get such a crazy answer that I'm like, I need to check that and make sure it's right. And then I'm like reassured. I know it's right because I checked it and it works. So type that in your calculator. 3 raised to that full decimal, and you will get 2.49. So Anyways, that's how you can check it. Did you get that?
Got it around.
Yes, and you have to type in the full decimal. Yeah. So our answer, we'll round to 4 decimal places, 0.8304. This is the answer I would accept. To check it, you have to type in the full decimal. Do you all understand that? Okay, awesome. All right, are you guys comfortable to do the rest of those?
Yep.
Okay, awesome. Go through 24. Ready, set, go. Quickly, because we haven't even got to the good stuff yet. And I don't mean to rush you, but just work quickly, please. Taking notes. Here we go. This is where we're getting into the good stuff. Right here. Okay. So now we're going to learn properties of logarithms. The reason we have to learn these is because if you want to be able to solve a logarithmic equation, you have to know your properties of exponents. You guys, there's such a good chance that you run into solving logarithmic equations on an ACT. And you will run into them on the end of levels. Okay, so we know now that exponentials and logs are inverses of each other. Well, guys, we know the properties of exponents, and exponents are exponentials. We know properties of exponents. The nice thing is they go hand in hand with our properties of logs. Because logs are inverses of exponentials, we don't have to really learn much new but how to apply it to logs. The song still works. When you multiply, you add. When you divide, then you subtract. And then something raised to a power, then you would multiply. So that song works with these as well. So the product property, product means multiplication. So if we have log to the base b of m times m, we can break it apart, split it apart, and rewrite it as log to the base b of m plus log to the base b of n. Guys, multiply you add. Do you see the connection there? So I split it up. Log to the base b. They're both log to the base b, which makes sense. They were here as well. And then it's m plus log to the base b of n. Okay? Now we're gonna have to be able to go both ways. Really, the most important part is taking something like this and rewriting it like this. So we're gonna have to go both ways. Okay, quotient property. So if we have log to the base b of m divided by n, when you divide then you subtract, we can split it apart by saying log to the base b of m minus log to the base b of n. Once again, the more important thing is that you can go this way. Given something like this, log to the base b of m minus log to the base b of n. When you divide, then you subtract. When you subtract, then you divide. So when you subtract, you divide. Does everybody see that? Are you making a connection here? If you're making a connection, it's going to be a lot easier for you. And then power property. Log to the base b of m raised to the n power. With this one, we're going to grab our n, the exponent, and bring it down in front. Because then we're multiplying n times log to the base b of m. Now you're going to see me do this. You're going to see me write it like this. I'm going to grab this and pull it down in front. Raise a power to a power and you multiply, so we're multiplying that in front. So I'm going to write it like this. Now once again, the really more important thing is that we can go this way. So if you have something multiplied in front, then that's just the exponent. We'll pull it back up into the exponent. So we have to be able to switch back and forth. Is everybody ready to practice these? Okay, here we go. We're going to condense the logarithm, write it as one log. So we're going backwards. So we have log to the base 4 of 5x plus log to the base 4 of 3x. Now understand something. If they didn't have the same base, you could not put it into one logarithm. But these do. So log to the base 4 of 5x plus log to the base 4 of 3x. So we're pulling this into one logarithm. So we know since it's log to the base 4, we're going to have a log to the base 4. Now, we're adding these things, so when you multiply, you add. And that goes as well as the other way. When you add, you multiply. So because of the addition sign, we're going to be multiplying 5x times 3x. So 5x times 3x.
15x.
Very good. And then our last step would be to, simplify it. So log to the base 4 of 15
Squared.
squared. Very good. You didn't make that error. If you would have, that would have been bad. X times x is x squared. Does everybody see how I did that? We're all feeling okay.
Yeah.
Okay, let's do another one. Paying close attention here.
Okay.
Log to the base 2 of 9 minus log to the base 2 of 3. Well, they're both log to the base 2. We want to rewrite it as one log. So we're going to definitely have log to the base 2. Now since it's 9 minus 3, we're going to be, when you divide, you subtract. When you subtract, you divide. So we're going to be doing 9 divided, because of the subtraction sign, 3. Does everybody get it?
Yeah.
So then we have log to the base 2 of 3. 9 divided by 3 is 3. And then from there, this is like very likely that you would see something like this on an ACT. And then they'd say evaluate the log. So first you'd pull it back into 1 log, and then you'd use the change of base formula. Do you understand that?
Wait, is it supposed to be divided or is it supposed to be?
When you divide, you subtract. So and both ways. So when you subtract, you divide. Does that make sense?
Yeah, I was.
So then from there, you would do log of 3 over log of 2. I'm just asking you to write it as 1 log. Is everybody okay with that? No questions. If you don't ask, I have no idea what to answer. Okay. All right, last one. This one's a little bit more difficult. Everybody watching very carefully, because there's one huge, very important step here. So we have 2 times log to the base 4 of 6 minus log to the base 4 of 9. Well, this is the most important thing. With your eyes, every single time, you need to look and see if there's any multiplication that you need to fix first. So looking at this, do you see the 2 multiplied to the log to the base 4? Okay, we need to fix that. So we know that that needs to be grabbed and put back up in the exponent. When you multiply, raise a power to a power and you multiply. So that's why it's multiplied. Anyways, we fix that by pulling it back up. So we're going to have log to the base 4 of 6 raised to the 2nd power. Is everybody okay with that? Very first step, you take care of multiplication first. And then minus log to the base 4 of 9. And now we can go through and simplify this by putting it into 1 log. They're both log to the base 4, so it's going to be log to the base 4. And then when you divide, you subtract, or when you subtract, you divide. So we're going to be doing 6 squared
36.
divided by, when you subtract, you divide, divided by 9. So what we have then is log to the base 4 of 36 over 9.
4.
Which is 4. So we have log to the base 4 of 4. Does everybody get it? Now if you wanted to calculate that, you could do the change of base formula. You would do log of 4 divided by log of 4. And you get 1. Anything divided by itself is 1, right? Anyway, I'm just having you condense it. I'm just helping make connections here. Any questions on that? Yeah.
Does it matter if you put the 2?
The 2, yes, the 2 was multiplied to the log of base 4 of 6, so the 2 has to go back up on the 6.
So if it was on this negative part?
Great question. Yeah, so if it would have been right here, we wouldn't pull the negative. That's just our divide part. But we would have grabbed the 2 and put it up on the 9. Yeah, good question. All right. Do you want me to do this last one?
Yes, please.
Okay, here we go. So we have 1/2 times log to the base 5 of x minus 3 times log to the base 5 of y. Okay, so we're going to condense this writing a single logarithm. First things first, you always fix what's being multiplied into the, and write it as an exponent. So that's being multiplied, so that's truly an exponent. And then this 3 is being multiplied, so that's also an exponent. Now do not pull that negative through with it. That negative's our divide part. So what we have is log to the base 5 of x raised to the 1/2 power. And then we have minus log to the base 5 of y raised to the 3rd power. First things first, always take care of those exponents. So if anything's multiplied, fix it. Everybody good up to there? No questions up to there? Okay, so then from there, we'll rewrite it using 1 log. Log to the base 5 of x to the 1/2, and then since we're subtracting, we're going to divide y cubed. Does everybody understand how I did that? Now, fun fact for you, they'll actually, and I'm going to push you to do this, the most simplified answer is to rewrite any rational exponent as a radical. So we're going to write it as log to the base 5 of the square root of x, root, power, everybody? Roots are on bottom, square root, power's on top. The square root of y to the over y to the 3rd. Does everybody understand that x to the 1/2 is the square root? Same thing. We're all okay. So this would be your final answer.
That's crazy.
It is a little bit crazy, isn't it? All right, are you guys ready to practice by yourself? Okay, now let's do number 14 together on your worksheet. log to the base 6 of 3 plus log to the base 6 of 2 over 3 plus log to the base 6 of 7 over 3. Now guys, this one throws people for a loop, but let's think about it differently. Let's rewrite this. Isn't this piece, so we have log to the base 6 of 3 and then plus right here. Wouldn't it be the same thing to say 1/3 times log to the base 6 of 2? Isn't this the same thing as this? Yes, right? 1/3 times log to the base 6 of 2. Don't you multiply straight across? And that'd be 1 times log to the base 6 of 2, which is log to the base 6 of 2. And then 3 times 1 is 3. Does everybody understand how I rewrote it? Yes or no? Do I need to show you in depth of why that is the same thing? Or do you understand that when you multiply fractions, you multiply straight across? Okay, I'm going to go more in depth then. So everybody look carefully. We have 1/3 log to the base 6 of 2. The reason it's the same is because this is the same thing as log to the base 6 of 2 over 1, right? Then we multiply straight across. 1 times log to the base 6 of 2 is log to the base 6 of 2. 3 times 1 is 3. So does everybody understand how you can go back and forth now? Okay. All right, so what we have is this. So you tell me, how will we rewrite this piece? Plus what? Oh, right here. Let's rewrite this piece. So what are we going to rewrite it as? 1/3 log to the base 6 of 7. And then we will grab our anything being multiplied, pull it back up into our exponent. Okay, you're doing good. Almost there. So then we would have log to the base 6 of 3 plus log to the base 6 of 2 raised to the 1/3 power plus log to the base 6 of 7 raised to the 1/3 power. Is everybody following me? And then we can rewrite it as one log. Now that we fixed it, all of our multiplication part, so log to the base 6 of 3, because it's add, we're going to multiply, right? 2 to the 1/3 times 7 to the 1/3, right? Since it's add again, it's multiply. Are we all following me? Because I'm feeling like a little bit afraid right now. Are you guys following me? Are you understanding what I'm doing here? Okay, so now we'll rewrite these as radicals. So we have log to the base 6 of 3 times the cube root of 2. Everybody, does it root power? Times the cube root of 7 to the 1st power. Is everybody following? Okay, now what do we know about radicals? If they're the same radical, can't we multiply what's under the same radical? Yes. So we would have log to the base 6 of 3 times by the cube root of, since these are both cube roots, you can multiply what's underneath them. 7 times 2 is 14. And that would be our answer. That's as far as we can go, right? We can't multiply 3 in. It's not under the same root. So guys, these problems, like I said, it's not like that they're hard, but they're kind of hard because they're very particular and every little thing matters. Is everybody okay with that? Okay. So let's have you practice 13 through 18. 13 through 18. Ready, set, go. So check your answer. Number 13. We have 24 log to the base 4 of 8 plus 4 log to the base 4 of 3. Okay, before we start pulling this into one log, we're going to fix any exponents. So whatever's being multiplied, that's the exponent up there, that'd be 24 up there. Does everybody understand that piece? Okay, then this 4 goes up in the exponent, so that's a 4 up there, the 4 is gone. Okay, so then from there, we have, I'll just show my work, log to the base 4 of 8 to the 24th plus log to the base 4 of 3 to the 4th. Does everybody get that? Now we have to rewrite it as one log. Well, we know it's going to be log to the base 4, and then because we're adding, when you multiply, you add. When you add, you multiply. So we're going to be doing this times this. So 8 raised to the 24th times 3 to the 4th. And then I'm okay for you to stop there. Now, could we Are these the same base? 8 and 3, not the same base. So we can't add our exponents, right? Right? Everybody understand what I'm saying? So I'll let you stop there. If you needed to calculate it, like if you needed to in the future, you could. You'll just type it in your calculator, but I'm asking you to stop there. Okay, continue. Check your answers with me. Let's go, let's go. Okay, so now we're going to expand the logarithm. Now we're going to be given a logarithm that's written as one log and break it apart. So everybody paying close attention. This is a totally shifting gears moment. We're now going backwards. So we're doing number 5 together. Okay? So we have log of x times y. So it's log to the base, what? 10. If it's not there, it goes without being said. But we're not going to write the 10. So we're multiplying these two things. When you multiply, you add. So we'll rewrite this as log of x plus log of y. Does everybody understand that? Now we don't write base 10, but I'm going to say log of the base 10 because it is base 10. Do you understand that? Okay. Don't write base 10. It goes without being said that it is base 10. I split it up with my plus sign because it's multiplication. Okay, I'm going to do another one.
Wait, that's all you do?
Yep, so everybody, this example is not from your worksheet because all the examples I was going to do wouldn't give you any practice. So look up here with me, you don't have to take notes, just watch. We have log to the base 2 of z to the 5th times y over x squared. We have a lot going on here. A lot. So the first things first is, I'm going to split it up. So log to the base 2 of z to the 5th, and then it's being multiplied by y. So shouldn't it be add? When you multiply, you add. So this will be plus log to the base 2 of y. Does everybody understand how I did that first top part? And then we have divided by x squared. When you divide, you subtract, right? When you subtract, you divide. When you divide, you subtract. So since this is divide, we're going to subtract log to the base 2 of x squared. Does everybody understand why I did subtraction? When you divide, you subtract. Do you all understand that? And then from there, our last step is to fix any exponents. This has a 5, it needs to come out in front. This has a 2, it needs to come out in front. I'm going to have you rewrite it. I'm not going to let you write it all sloppy and stop there. So what we have is 5 log to the base 2 of z plus log to the base 2 of y minus 2 log to the base 2 of x. What's easier, going backwards or the other way? Just curious. Bold. Okay. Do you need another example, or are you good? Should I do this one?
Yes.
Log to the base 2 of x v squared raised to the 3rd power. Is there an addition or subtraction sign between the x and v squared? No. So this is properties of exponents. It wouldn't be breaking the first rule to cube this. That is what we'll do. So what we really have here is log to the base 2 of x to the 3rd, right? Are you all paying attention? X to the 3rd, raise the power to a power, and you multiply. So x to the 3rd, v to the 6th. And then we would split it up. So we have log to the base 2 of x to the 3rd. Because it's multiplication, it'll be plus log to the base 2 of v to the 6th. Then we would fix our exponents. And you guys are good to fix those, right? I don't need to write it out. Are we all good with that? At least that part. Okay. Last thing is, oh no. So do problem 6, 7, 9, 10, 11, 12, 13. That's all I'm requiring for you to have done tomorrow. Don't cross out the others. We've got to finish this off tomorrow and then move on. But this is what's going to be required of you for tomorrow. So page 2 and 3, this has weird numbers on it. So page 2, which would mean the second page of the first. So here it is. Flip back, that's page 2. Behind the front page, and then into page 3. Does everybody get that?
It's going to be a bit easier to type in A.
You're right, you're right. But guys, if you feel comfortable doing, well, we already did 5 together. You can do 8 if you feel confident, which that should be okay. What's the square root of A? Rewrite it as a rational exponent and then continue. But anyways, this is what I'm requiring of you tomorrow. Do. But don't cross out the others. We've got to finish this up tomorrow. All right, good